and getting calls to, say, your sales line routed to a competitor instead. I mean, there is a validation that the number actually does belong to you before anyone uses it. There's a bunch of work in it that I didn't talk about making sure that this doesn't make a new method for us to get spam or spit or spam or whatever you want to call it, of more junk coming across these IP interfaces that was unwanted communications, right? Again, it's only people that you've had a PSTN call with. There's certain tickets that set up that are used as authorization tokens. And there was a lot of work done to make sure that there was a limited surface area for doing denial of service attacks. Next slide, please. So the real key parts of the technology that got put together to do this is several things. One is a distributed hash table, and this is the sort of the fundamental data structure that's being used in lots of peer-to-peer systems. It's a very different idea for how to build large distributed data centers. I mean, instead of having a data center that contains all of your information, why not just push it out to the actual edge nodes and have the people actually using and deploying the system store all of the data. So as more nodes get added to this system, more storage space gets added with it. It's very much a move it to the edge model. It makes for a very scalable type of system. We've run simulations up to billions of numbers. We like all that. Now, the security issue of knowing what names to use when you want to communicate with people and who owns those names, for that we really use the PSTN. We thought phone numbers are a very familiar addressing form that people love and are easy to use. It's not that we think they'll always be here forever, but they're a nice form of addressing that works well today for initiating communications. People are familiar with them. So we use that, but we need to use the PSTN to form the security of that. So we actually leverage the PSTN to understand who owns a phone number and who's authoritative for calls going to that number. Where should they get routed? And then finally, we combine SIP into it very much for the flexibility of the type of features that can be negotiated over it. Video and wideband being the top runner ones today, but really this is going to apply to anything going forward. This is a technology that allows you to map a phone number into a location for IP communications. So whether that's a XMPP feed that you're trying to do or find an HTML web page, all of those types of things can be done using this Viper technology. Next slide, please. So a real key part of all of this work was, when we were looking at it from the beginning, is did we want to do this as a proprietary type of system, or did we want to try and make this a very wide system that lots of people used? And Cisco has very strongly decided that what we want to do is make this very available for lots of communication systems. And what we're trying to achieve here is just simply the network effect. This system is far more valuable the more people you can reach using it. And yep, it reduces things like long distance expenses, but the real value in it is adding more features and things that work between people in an interoperable way. Now, if only Cisco systems supported it, it would have a value for that, but it would be more value to Cisco's end users if more systems than just Cisco systems supported it. So really to do that, we have made the patents and an IPR behind this. They're all in our, Cisco's usual don't bug us and we won't bug you type approach to our competitors can go and use them to implement all of this stuff. We've published all of the standards and design description that we think that people need to completely build interoperable systems that work with that. And some of the IETF drafts are up there right now. The basic work for the overall distributed hash table in that system is described in this reload document that we've been working on for a long time. The rest of the documents are specifically about how to build Viper on top of that and the technology for doing this validation. Probably best described in the overview document. And these are all right now joint author documents between myself and Jonathan Rosenberg, who's over at Skype. And we're working to try and encourage people to figure out how to build this type of technology in, because we think it can really totally change the direction of where the industry is going. It can make it just much easier to make all the types of things that IMTC has been working on forever, for voice, wideband, video, make that all far more accessible and just easy for people to use between businesses where it's most valuable. So with that, I'd like to open up to questions. I'm not sure if we've gotten any questions as we go, but that's where we are. So. Anatoly, can you pass on this?
Thank you. Thank you very much, Cullen. We're checking if we have any questions. So we'll know in a second.
Okay. Well,
Okay.
like all the speakers have said along the way here, I'm sure if people do have any questions about this, I'm clearly thrilled to talk about it anytime. So my email is easy to find or work through.
It was going to be 10 minutes late.
Questions.
Yeah.
Cullen, well, maybe I have a question, if I may. So, with all practical purposes, is you start shipping this stuff, or is it when do you guys actually ship this stuff?
Yeah, that's an excellent question. So we have it in trials with multiple different people right now, as sort of beta, alpha, and beta trials. We're running it inside Cisco between a lot of our sites internally right now. There's a ton of calls going on. I've been using it for about 6 months. It was announced at VoiceCon a couple weeks ago, and I don't know if our actual public ship date on that has been publicly announced, but I know at VoiceCon it was announced as very soon. So I might have to go actually ping the marketing people to find out what we're allowed to say about exact dates. But it's in use today, and it's very soon, is what we said at VoiceCon.
That's definitely a usual thing. And maybe one more question. So so your implementation versus, let's say, what Skype is doing, it's the same technology, different use, or because Skype is also DHT based, right?
So Skype does use DHTs for a bunch of things, including this type of thing, and that's the Skype that everyone's seen and used for many years is a very different technology than exactly what we're describing here. This is, Skype is a closed system where they use this DHTs to build a very scalable system with lots of their users. Now, what their plans are explicitly around this technology, they have not made any public statements I'm aware of at this point. But where Cisco's trying to go with this technology is, instead of building a closed system where one person controlled all the addresses and namespace, and if you wanted to become a user, you went and registered with that system. What we're trying to say is, hey, any vendor could go and implement these types of drafts, this code that we've been talking about. If you already have a phone number, you have an address in this system, and that's all you need. And so there's no Cisco lock-in or requirement for Cisco equipment or anything like that in this space. Anybody could take these drafts. Two different large video conferencing companies could both go and implement this, and this would provide a way that when they customers dialed each other's numbers, we have interoperability, which we view as a great thing for the industry.
So pretty much you're saying that technology is effectively available, and so Cisco builds the products, but everybody else can build the products based on the same technology, right?
Exactly.
So that's pretty much the idea.
And
and
we realize that as it goes through the standardization process, this technology will change and adapt the actual protocol and the wire and stuff, and we're looking for people to work with on making that happen.
Excellent. Okay, I think we don't have any more questions. So again, thank you very much. Again, my apologies for the hiccup with the slides. We're still apparently enhancing the technology. So thank you very much, Cullen.
No worry, and thank you very much for being able to present here today. I appreciate it. And anyone who wants to talk to me, fluffy@cisco.com. Thanks.
Thank you.